Okay, so this lesson is Operations with Functions, week 11, lesson 3. You can find this in chapter 10.6 in your textbook. Okay, you will find that this lesson is actually very similar to what we did in class. There's not a whole lot new to this, so this should be a good refresher for you. So the first thing I want to talk about is when we are adding functions. So the first thing I want to note is here, it says f plus g of x. That is the same thing as saying you take the function f and you add it to the function g. It's just a different way of notating it. And in this one, they give us two functions. So function f is a linear function and function g is a quadratic. So there's two ways to do this, and we did this in class. You could set it up and you can add like terms horizontally. That's fine. I personally prefer to line them up vertically. And I tried to line up my like terms on top of each other. So my first equation, f of x is 2x minus 3. And when I line g of x up, I'm going to put 2x squared over here. So that way my x's now line up and now my constants line up. Okay. So you can kind of see, I don't know, let me see if I can draw lines down. So do you see how all the like terms are set up vertically? So in this case, we are going to add them. So I have 0x squareds plus 2x squareds, which gives me 2x squared. I have 2x's plus 1x gives me 3x, so positive 3x. And negative 3 plus 7 gives me positive 4. So my final answer is 2x squared plus 3x plus 4. Now you can also do it the horizontal way. That's fine. Just make sure that you, again, are doing like terms. So in this case, our biggest one by degree is the x squareds. There's no x squareds on the left, but there is one here on the right. So that's where the 2x squared comes from. Then you have the 2x gets added to the x to make the 3x. And then negative 3 gets added to the 7 to make the positive 4. So you'll get the same answer either way. It's personal preference, but I do know when we did this in class, a lot of you preferred to set it up vertically. Okay, subtraction is the exact same thing. Be careful with this one because they have reversed it. So they want us to take g of x and subtract f of x. And the order does matter when you're subtracting. So again, you can set up vertically or horizontally. It's completely up to you. And my caution is to make sure that you pay attention to the signs, okay? So let me go ahead and set this up vertically because that's how I prefer to do it. Okay, again, my g of x comes first, and then I'm taking away my f of x, which is the 2x minus 3. Now, if you remember in class, we talked about changing the signs. We change the signs so that way we are adding instead of subtracting. So if I change this into an addition problem, I have to change the signs of everything in the second row. So instead of being positive 2x, it becomes negative, and the negative 3 becomes positive. And this just makes it easier because now I can add. I don't have to worry about subtracting at all. Okay, so again, you can start from left or right. It doesn't matter. So in this one, I have 2x squared plus there's nothing down here, so that would be 2x squared. Positive 1x plus negative 2x gives me negative x. Okay, and you can always add a 1 in there if you want to see the number. And then 7 plus 3 gives me my positive 10. So that would be my final answer. You do get the same thing over if you do it horizontally. Just remember that 2x squared has no like terms, so you keep it. And if you're doing the changing sign thing, just make sure that you change this to a plus and then these become the opposite signs. You only change the second one, okay? And then you would keep on going from there. But like I said, I think vertical is a little bit easier, completely up to you, whatever way you prefer. All right, so here's the try it for this section. They give us f of x and they give us g of x and they want us to subtract them. So pause the video, give this one a shot, and then come back and check your answer. All right, so I am again going to set up vertically. So my f of x function is 15x squared minus 8x plus 4. And I'm going to put my 11x plus 6 lining up my like terms. So everything is nice and vertical. and this is subtraction. Now remember, I don't like subtraction, so we're going to change them all to addition. So if I change the problem to an addition symbol, I have to change the signs of all the second ones. Okay? All right, so 15x squared plus nothing is 15x squared. Negative 8x plus negative 11x is negative 19x. And 4 plus negative 6 is negative 2. Okay, and that would be my final answer. All right, multiplying function. So this is the one that you guys had no problem with during our class when we did these. Again, just make note of the notation. If they say f times g of x, they just mean take the f function, multiply it by the g function. In this case, we have two ways that we can do this. The first way is FOIL. So let me show you that first. So FOIL stands for first, outer, inside, last, or first, outside, inside, last, whatever way you want to say it. So if I were to take my two functions, and I'm just going to put them in parentheses, if I say 9x plus 20, and then x plus 5. All right, I like to draw the little lines because it helps me remember which ones I'm doing. So F stands for first. So the first term of the first one times the first term of the second one. So we have 9x times x. Well, 9 times 1 is 9, and x times x is x squared. Okay. Then the outside would be the first term of the first one times the last one. They're the two outside numbers. Okay, first and the last. So 9x times 5, well, 9 times 5 is 45. And there's only one x, so I keep the 1x. Okay. I stands for inside, so the two that are inside would be 20 times x, which is 20x. And L is my last, which would be the last term times the last term. So the 20 times the 5, so that would give me 100. Okay. And so, like I said, it's kind of like distributing. Distribute the 9x to both, then distribute the 20 to both. Now we have to combine like terms. So our 45 and our 20 can be combined together. So we end up with 9x squared plus 65x plus 100. And that will be our final answer. Okay, so some of you really liked FOIL. That's fine. We had also talked about the box method. And the reason why I kind of stress the box method, I let you guys choose, but the box method will work no matter how many terms these have. Both of these were binomials. It was a binomial times a binomial, which is easy to do FOIL with. Sometimes if you have a trinomial times a binomial or a polynomial times a trinomial, the box is a little bit easier to keep things neat. But for instance, we're doing a binomial times binomial. We just need to draw a 2x2 box. Okay. So what I'm going to do is I need to put my f of x on one side, g of x on the other. It doesn't matter as long as you keep them on the same side. So like if I put 9x over here, I have to put the plus 20 underneath of it to be on the same side. Okay. And then that means x and positive 5 go across the top. All right. And then we multiply all of the pieces to get what's going to go inside. So 9x times x, remember this is like saying 1x. 9 times 1 is 9. X times x, there's two x's there, so I get x squared. Okay, 9x times 5. 9 times 5, we said was 45, and there's only one x between those two numbers. All right, 20 times 1x. So 20 times 1 is 20, and there is 1x. And then 20 times 5 is 100. There is no x's, so that one doesn't get any. And then if you remember, we have to, again, combine like terms. So to combine like terms in the box, normally it's on the diagonal. Just be careful. Make sure that they are like terms. Sometimes you may be missing a term. Just make sure they are the same. So with our like terms, we add. So in this case, 9x squared has nobody to add with. 20x and 45x give us our 65x. And our 100 has nothing to go with, so we keep 100, and that ends up being our answer. So as you can see, we can get the same answer two different ways. It is completely up to you, whichever way you prefer. Just make sure you remember your laws of exponents, that when we're multiplying like bases, we have to add the exponents. Okay, so the classwork for this one is page 448 to 449, numbers 5 through 10, 17, and 19. The exit ticket is on page 449, numbers 16 and 18. Please make sure you turn those in to me. I am available on Blackboard Collaborate if you need some help. You can email them to me, send them to me through the drive, or submit it directly onto Schoology. Thanks.